It's amazing to see how many people have already found their way into the conference and into this meeting room. So welcome everybody early today for this last day of the Inspire conference 2017. We have a session this morning about Inspire and LinkedData. I've been looking at the presentations. Some of them clearly express it in the title. We'll have some which maybe looking at this a little bit around. We'll find out as we go. And my name is Stefan Jensen. I'm the chairman here of the session from the European Environment Agency, involved with the team in Inspire implementation, coordinating this. And we have as a first presenter somebody who has been working since more than a decade. Is it 20 years already, Clemens? No, that's not possible. Yes, of course, in the Inspire area. So Clemens has found out something new, I guess, and he will speak about spatial data on the web, tools and guidance for data providers. Clemens.
Thank you, Stefan. And also very good morning for me. Very impressive to have this turnout at 9 o'clock. I haven't seen a session at 9 o'clock that was that full from the beginning. So where are we? All right, so my presentation doesn't have LinkedData in the title, and in a way, it's also not really about LinkedData if you think LinkedData is RDF. For me, LinkedData is everything that follows the web principles. So in that sense, it's fitting to be in the LinkedData session, but it's not really about semantic web and these kind of topics. It represents what I will be talking about here is work that builds on other work. You will see that later, and is based on work that we are doing. I'm from Interactive Instruments, a company in Germany that we're doing for JRC in the ELISE project. So let me try to explain some of the limitations that we have in our SDI architectures. That includes then, of course, Inspire, and how that relates to the topic with spatial data on the web. So the background is that what I think we all want is that we make the spatial data available not only to geo experts, to GIS specialists, but also to others, and make that as simple as possible for those to integrate location information. So when we look at how it actually works, if I'm someone who's searching for data and want to see what data exists and can I use that data, how does it work in our SDI? So the typical thing is you search via a geoportal. I used here the Inspire geoportal. So you open the geoportal in the browser, and of course that only works if you know that there are geoportals and how to find them. So most people search with the search engine. So then I navigate to the search somehow. I add some text, potentially structured search criteria, and then I can find results and search, go through them, browse the metadata records, select the result that I want to investigate further. Then I look at the metadata, and the metadata that we're using in Inspire and in the most of the GI community, the ISO standardized metadata, that's really for GIS specialists. I mean, for me, it's most often confusing what I find in there and hard to read and understand. And it's even more for others who don't really know the standard and the structure and the stuff that is in there. And maybe somewhere I can find a link to somewhere where I can get the data. Not always, actually. But here I took a case, so there was in that metadata record, there was a link download service. So I clicked on it, and I get this. So that's a WFS capabilities file. And of course, I need to know what to do with it. If I've expected the data set, I'm kind of stuck because the browser doesn't know what to do with it. It just knows it's XML. It doesn't know what it is, what WFS capabilities document is and how to make use of it. So what I need to know is I need a specific application. What I actually then have to do as a GIS specialist, I open my software, so ArcGIS or QGIS as it's shown here, or whatever your favorite GIS, which maybe supports WFS. So you copy the URL and you follow then the process of adding the WFS. So that again, you need extra knowledge and how to actually work with that data. And then, of course, you can use the data, click through it, and quite often it's also hard to understand the data. So maybe you have attributes like building types. They have a code 1, 2, 3, 4, and who knows what 1, 2, 3, 4 is? Is it a house for where people live, or is it a shop or whatever? So it's often hard to get the information to really understand the data. That is also an issue. But what are typical expectations of people, how they use the web? So you go to your search engine, you enter the search criteria in this one bar, you click on something, you get results. Hopefully something is there that you want to look further. You click through it, and then you can browse through the data set itself. You go to a web page, you look at the information there, and that should give you the idea of what this data is about. And then you can decide whether, if you can download it, you download it and then process it, or if it has an API documentation, you go to the API documentation. You use typically public free libraries that help you to actually manage that data, if it's GeoJSON, GML, or whatever. So the typical thing is you use the standard tools and mechanisms of the platform. In this case, what we're looking at is the web, and the differences that we see from what I describe here and what has been developed basically in the SDI architectures is the result of 20 years. The web, as it's implemented in our SDIs, basically 20 years ago, it was completely different. And the practices were different, the expectations. And 20 years ago, it was basically super state-of-the-art that was done. But it's no longer the case. So, and I think it's one of the things is we need to see how we can evolve with the changing landscape. So that's one of the things that also in the standards domain, there's been long discussions about that, and actually 3-4 years ago, work started, or there was activity workshops, and that led to a joint working group between W3C, so the consortium, standards consortium that works on the web standards, and OGC as the standards organization. All right, I can still see it. And there was a joint working group that actually worked on one of the topics is spatial data on the web. That's from the title. Not to create new standards, but to summarize the best practices. There's other work items that are more LinkedData oriented, which develop ontologies for sensors, observations, etc. But what I focus on here, so basically there are 14 best practices that make recommendations on things that you should do when you put your spatial data on the web as a data provider. So it's also oriented towards data providers, but the goal really is to make it easy for web developers or others that actually want to access that data. We have a spatial data on a web best practice, but of course spatial is only to a limited extent special. There is actually another best practice that's just a straight W3C best practice document that was finalized early this year, which is on data on the web best practices in general, and that has more than 30 best practices. And the spatial data on the web best practice, they just refer to that and add things where there's something special in spatial about geometries, coordinate reference systems, and also in some cases where our community hasn't really adopted some of the web architectural principles to highlight that. So what are we trying to do? And that also then goes to the activity that we're doing in the ELISE project, is we're looking at the infrastructure that we have in Inspire and see, okay, what are we missing? What would need to be done to actually improve and make the data available to others on the web, but in a way, I will explain that afterwards, that we don't, let's say, disrupt the infrastructure. Infrastructure needs stability, but the key things that we're trying to do is we want to create a presence on the web of data. So our data isn't typically indexed by search engines. Maybe through some mechanisms, the metadata is indexed, so metadata of services or metadata of the data sets, but the data itself isn't indexed. So we need to make sure that resources have persistent URIs, that all the resources are linked. So when I got the WFS capabilities URL, there are no links to the data. I need an application that somehow knows how I get from the capabilities to the data. That's not very web-like. So that these are all these are actually key aspects of it. So and also harmonization of data discovery. We need to use the mechanisms that are used on the web. We need to support the vocabularies that the search engines understand, and so that people can discover the resources using their standard ways, the search engines, not just the non-spatial data, but also our data that our community provides. And then we need to support multiple representations. So in addition to GML that we currently have, also JSON, GeoJSON is a good thing because it's broadly supported also by software tools, etc. Maybe also RDF representation, so we use JSON LD. But the important thing is also, and I think that was missed 20 years ago, is when you want to put data on the web, you also need to think about HTML, because if you don't have HTML, you are not really on the web. So you need the links, but you also need HTML and with structured annotations that search engines understand. So basically the idea that we're following from an architecture principle is that you see on the bottom, you see the Inspire SDI architecture with our WFSs, CSWs, so discovery services, download services. And then we're looking at a proxy layer that actually changes or provides a view to that is focused on just the web principles and simplifies that. So we only look at WGS84 at this point. We want to support HTTP content negotiation. We want to make things linkable. We want to have simple APIs, etc. We want to support schema.org. That's the vocabularies that search engines understand. So what we actually did with Interactive Instruments as a company started in a testbed that was organized by GeoNovum 1.5 years ago, 2 years ago. In parallel to that W3C OGC activity, a testbed on spatial data on the web, and we actually developed an open source software. We call that LD proxy. So there is a little bit of linked data, the LD is for linked data, in it, to actually experiment with that, because it's still in an experimentation phase what we can do. And here are some links, also the report from that testbed that we have. So that's an example that we have here. That's just a view. That's live access to a capabilities document, basically, and Inspire capabilities. WFS presented in HTML. It has schema.org annotations, etc., or also a feature. So, and that's one of the key challenges. Is also when we go to HTML is to make it actually understandable and usable. So people can there is a protected sites link. With that, I can actually follow links to get to each individual feature. I can do that. So as a developer, I can browse through the data and see, does it have information that's relevant for me? Or I can download it, but also the search engines can actually do that. So I can, if it's there and it's indexed, then I can find information for this protected site, for example.
2 minutes, Clemens.
Yeah. So what we're doing in this current activity is two things. One is actually documenting the work, and the second is doing some improvements on that software to simplify. It's an experimentation tool, as I mentioned, so it was hard to use in a way. So we simplify deployment. We want to make it configurable via a graphical user interface in the browser, harvesting discovery services to set up all the WFS proxies for all the WFSs. We need to be more fault tolerant against WFSs, and there are in that report many other ideas that should be explored to see whether that helps making our data more accessible. I just want to mention two things. One of the big topics is, I think, how we can make the data itself and then also the HTML more useful for humans, so that people want to link to that, which will also help then with indexing and ranking in searches, etc. And then, of course, we need to follow also the web with how they use APIs. The big thing is Swagger, or now the Open API initiative. And linking is, of course, one thing. I just want to close that. That's from the GeoNovum testbed. So, for example, there an address in the Netherlands, I can find it. It's actually ldproxy.net. You see that that's the first hit. I mean, there are many open questions how search engines are actually indexing data or not. But that's an example that you can find it, and that's also an example here for the structured data. So in the HTML, Google or other search, Bing, see that it's an address, where it is, etc. So it has lots of information, even if it's an HTML page. Thank you very much.
Thanks, Clemens, for introducing us to these good recommendations, how to be modern on the web with our stuff, so to say. Questions to Clemens? Martin?
Thanks a lot. Just a flash one from those tasks you showed, and even the architecture schema. From the organizational point of view, do you think it is realistic to expect that if the things will go in the direction you just depicted, it will be possible for example, national INSPAR coordinators to release the burden on the data providers and actually to ask or expect that if the data providers will provide the data for the download through the WFS, is it feasible to establish some sort of centralized component on national level which will be doing all these things on behalf of the data providers to make their life easier and actually to achieve what is expected to be achieved with this initiative?
To be honest, I don't really know. I mean, as I said, we need to experiment how it can work in a good way. I think we have the infrastructure, and we should keep the infrastructure and build on it. And basically, the capabilities would still be there. You would just get it through another mechanism. And that's the assumption. This is the right way to go, right? I mean, that's just an assumption, and that also needs to be tested. And then, when that is there and people are convinced, then it's another question on how to actually implement that. But from our experience, let's say, basically the proxy is a very small layer, and it doesn't add much complexity to it. So the performance is basically exactly the performance of the WFS. I mean, it doesn't store any data, cache any data. You can think about, but of course then, if your infrastructure at the bottom is good, then you can do it. But then it's also the question is, as long as we want to support both, that's clearly a feasible mechanism. And that's also why we did this harvesting of a discovery service to set up multiple services. But you we'll have an update at the end of the year with more results from the experiments.
short reflection as well myself, just a second. We started with the Inspire GeoPortal. I mean, do I understand that through these technologies, something like this LD proxy, we will be soon able to see the content of the Inspire GeoPortal better retrievable on the web? All this rich content. Is that a correct assumption?
Well, it's no, I can't really say that. I mean, it's also
option forward at least.
Well, definitely, but it's more than that. I mean, it's the GeoPortal has the metadata, right?
And we want
But
to find it in Google, let's say.
yeah, but not only the metadata. You want to find the data,
Yeah.
right? So and with that, if I put in the name of a protected site, I will never find it through the GeoPortal because that's in the data. But if I'm, but so it's more than that, but probably not all the data that is in. We need to, if you want to be found on the web, you need to use the vocabularies that the search engines are using and not our own, right? So that's the key point. But basically, and I'm not saying, I mean, I'm not sure how important GeoPortals will be in 10 years. I think they will be less important, but maybe they will still have a role. But it's quite clear that the search engines are key.
That's what we say. Very short question and very short answer from the gentleman over there.
Yes, when I look at that recommendation paper, I understand you've tested it using a proxy implementation at the moment, but it feels to me like this calls for potentially a new service specification that would sit next to WFS. Do you see it like that? And does the OGC see it like that, and maybe would follow that recommendation paper with a potential new specification?
So that's another thing. There is a discussion about that, of course. I mean, it's an OGC best practice paper, so there is a discussion on what OGC does with that. Has started. That's the version from May. It's a draft version, but it's almost finished. And actually, OGC voted to make it an OGC best practice. The current idea, I mean, is I made a change proposal, and I'm working on a proposal for WFS, next version of WFS, that basically has the capabilities, but using open API, Swagger, etc. So there are big architectural changes, and I think because it's the same capabilities, or well, I shouldn't say capabilities because that people think about XML, but the same characteristics that a WFS can support. So I think it can also be a new version of a WFS, and it doesn't have to sit on top. It can also be a straight implementation of that. So I think what I'm trying to do is bring it together. Yeah.
Okay, Kevin. Sorry, we need to move on. Lorena is waiting to present to us about Inspire and RDF. The title is called here, and we'll hear the details from Lorena, and the presentation is up. Thank you.
So, good morning to everyone. My name is Lorena Hernandez. I work as an external consultant for the Joint Research Center, and I'm bringing you the outcomes of the activities that we've achieved under the ARENA action. So, as you all know, Inspire aims at improving the exchange of interoperable spatial data between public authorities in Europe. And this is normally done under the spatial standards as the Open Geospatial Consortium ones. But while the implementation is ongoing, other technologies are appearing, and this is the case of LinkedData. As we've just seen in the former presentation, there is already the spatial data on the web best practice that have been released early this year. And they recognize that the location is often the common factor across multiple data sets. So it's a useful data to include in the links for LinkedData. Before these recommendations, there was also work done by ISA on the core location vocabulary to allow including this information in the e-government processes. There are other vocabularies as well. And we have to recognize as well that we are not the first ones. That there are already some pioneers trying to move the geospatial data to LinkedData. And regarding Inspire, you may have already heard about GeoNow and PDOK. So since Inspire is a long implementation process, it should be flexible enough, and it should at least assess if the new trends, the new technological trends could bring them benefits. And this is why Arena is working on LinkedData. It has already some background dealing with at the metadata level. We developed the GeoData specification, which allows communicating, exchanging metadata from geospatial catalogs with OpenData catalogs, and we also put in place a sandbox, which is available in the Inspire website if you want to try out how the GeoData works. And but this was not enough. We wanted to go at the level of data, and to do that, we do it in 2 different phases. In the first phase, we did a study on RDF and persistent identifiers, and that was the base for applying the knowledge that we got. And this is exactly what I'm going to present now, the draft guidelines and vocabularies that we've produced, and the 2 pilots that are testing that have tested the feasibility of them. So both the guidelines and the vocabulary have been produced by interactive instruments, and we have had support from PwC. The goal, as you know, is keeping the Inspire interoperability in the LinkedData world. And this has been done through an open process by adding issues in GitHub. It is still open, so you can still make your comments. I want to highlight, before going ahead, that this activity is still draft. It needs to be reviewed by the MIG representatives. And if they think that there is a benefit on it, it may turn in an additional encoding for the geospatial data exchange. Additional doesn't mean that it replaces what it is already done. It's simply, it could be an optional encoding. So the guidelines were produced because we have a requirement in the regulation 1089 that all the encoding rules must be documented as ISO 19118, and they should include the schema conversion rules, that is the rules to convert the Inspire application schema to OWL ontology, and also the instance conversion rules, that is to convert the actual data. And those form part of 2 of the most relevant chapters of the guidelines. Here you can have an overview of the cover of the guidelines. It's actually also an experiment regarding new ways that we could have in providing new specifications, because it's an HTML version of it, and it could also be more flexible to maintain. So if you want to have a look, there's the link. As all the guidelines, there are requirements, there are recommendations, but we also have permissions, and there are also relevant issues, open issues that are being documented in GitHub. Here, for example, I took an issue on the voidable properties of Inspire. This artifact in Inspire has not really a match in the RDF world. So for the time being, we have, let's say, kind of loss of information, and we can only share all the positive information that the data provider has. So regarding the RDF vocabularies, we produced some vocabularies for some things. For the time being, we want that it to be in an iterative process to learn from it, and we focus in particular to in the themes that were relevant for the pilots that I will present later. And in the first place, you can see the beginning of these vocabularies, where they say exactly how they made the alignments and mappings and omissions, if they are. So if we go more in depth into the vocabularies, you can see on the left side the common UML application schema, let's say, and in the other side, how the vocabulary is represented. You can see that, for example, I took the example of the man-made object. You can see that it is a class, that it is also a subclass of Hydra object and GSP feature. And if you look to the different colors, you will see that it's not only about class. We also include the object properties and the data properties. And this is an example of a converted instance provided by Waddletel from the hydrographical physical waters dataset. And you can see more or less how the output is. So coming to the pilots, the GRC has awarded 2 pilots from a call of tenders that have run until 2 or 3 months ago. Yes. Both pilots involve the private companies, and they focus on e-government applications. The goals were, of course, to demonstrate the feasibility of sharing Inspire as RDF, and also to improve the guidelines, and to see which use cases could involve them and which benefits of this technology the piloting partners could see. So the pilot one was on improving the information position of emergency responders with linked Inspire data. It was done by NetEdge, which is a Dutch company that specializes in applications for emergency response, as its motto says, smart data for smarter firefighters. The stakeholders were the Dutch cadasters, which provided the data, and the Dutch safety regions, which are a cooperation of public villages and public authorities from villages and towns to help in the disaster management within every region. The business case was, the goal was to combine different public and private data sets to generate an accurate contextual image that was relevant for the fire service for all the process of their duty, preparation, prevention, and operations. It's important to see that the fire service has no authority over this data, so they need to harvest it. Relevant information for them is a building, especially the size, the type of business registered in the company register, and also the activities allowed in the permit register, and of course as well address and parcel register. I won't go through the process, but those will be soon included in the Inspire in Practice platform as some of the possible reuse cases. The issues that they encountered were mainly during the process of fit, because they found a mix of Inspire and non-Inspire themes, and also because it was a bit weird for them. A dwelling could be referred in different Inspire themes as building, facilities, addresses, and so on. And also they discovered that they had an excess of triples, and they only focus on one city. I didn't say that before. And I don't know if that could be an issue for usability. And then regarding the benefits, they proved that what they call administrative relations, that is not only spatial relations. In that case, they give a very interesting example, the difference between physical location and administrative location. This is really useful for them, and they do not always find it in the spatial data. So they rely on that for the linked data, and they prove that this is more beneficial. And they also found benefits in the simplifications of the update and combination of the data sets by keeping the data of the data at its source, and do not producing any other silos. And they also assured that the Inspiring RDF is suitable for cross-reference scenarios. And it provides more business intelligence and more advanced analysis for them. And now I invite Jose Enrique from Waddletel, who will explain his pilot.
You got 4 minutes. Thank you.
Enough. We have in our pilot to index Inspire data into RDF, we had several stakeholders, CENIC, from which we obtained the data in Inspire format, and then we managed to transform it to RDF and publish it. And then the Guadalquivir River Basin Agency, which is eager to incorporate RDF services in their internal business processes. There are also another stakeholders, of course us, and also the Andalusian Regional Government Corporate GIS, which is also interested in spreading these Inspire RDF guidelines and tools, so they can make an horizontal tool for all the different organism of the region. The process, I'll go very fast. It was just the main objective was to provide the information in RDF. So we downloaded the data using WFS 2.0 from CENIG, and then we made a quality check for Inspire compliance. It was 100% compliant, so we could establish a correspondence between the vocabularies, as Lorena has shown before, between the Inspire classic data model and the vocabularies, the RDF data model, let's say. Then we make an ETL, and finally we publish it in a RDF service using Virtuoso. We have found several issues and challenges to be tackled during this process. It's not a straightforward process, but at business level and at technical level we have faced some issues. One of them is that there is a complete lack of references for GIS RDF data. There is not much references in the website, in the World Wide Web, so the Inspire RDF guidelines are really useful in that to tackle this issue. And then we have also detected a great lack of resources and business priorities in all the organisms we have contacted with, because not only resources, understanding it as money, but also as knowledge. So as they start to know what are the benefits of RDF and LinkedData, they start to realize how important it can be in the future. So in this case, the way to tackle it is to make the information and the knowledge more available, and also enrich some success cases so people can realize the benefits of RDF. And finally, the benefits perceived are directly derived from the use of web semantic. You can link spatial and non-spatial data using vocabularies. You can index the information in machine-to-machine searches if you put the correct links in your web page and so on. And for the concrete case of the hydrography physical that we have made, you can make a cross-sectorial reuse of the published data for example, floods, transport planning, or agriculture. These are the main benefits, and say it in 3 minutes. Okay, thank you.
Thank you.
So in 1 minute, I have it yet. So those pilots were very useful for us, as I said, for improving the guidelines, but they also provide with additional outcomes. We produced a webinar. If you want to see more details, we have the link there. Otherwise, you can see them as well in the reference page that comes in the end. We also get a lot of documentation that we will add to the Inspiring Practice platform. We had interviews with different stakeholders to have more insights on it, and we have a very detailed Virtuoso migration guidelines provided as well by Wadatel that we will make public. So summarizing, the overall benefits are in terms of discoverability, reuse, and linkability. Regarding reuse, I would point out that we could have new actors that goes beyond geographical information, and that could take new technologies and also new business and use cases. And in conclusion, is simply saying that W3C has already had a say and sees the value of the spatial data as linked data. If Inspire approves this new encoding, it could symbolize the willingness of being in the last trend, the technological trends. And that's all.
Thank you. Thanks a lot to both of you. I think that was cool. I mean, to first develop the ideas, then having the pilots showing the results. Great. Questions? In the meantime, some people can try to come in. There's actually one seat left over there, and then one over there, but maybe still come a bit up front. There was, yes?
I just have one question. Does the webinar present actual tools that you can use to transform RDF data so that we might... does the webinar that you presented include actual tools or workflows to get from Inspire GML data to RDF data? so that we can try ourselves to do these transformations?
In the webinars, they mentioned the tools they used, and they mentioned in theory how they did it. But as I said, the detailed information on how to make the process will be made available soon through the Inspiring Practice platform. And we will also provide the migration guidelines that Guadaltel produced. Exactly with, I mean, I think it covers from setting up Virtuoso to uploading it and so on. So we will share that.
Yeah, thank you.
One last question. Yeah, in the first row.
Thank you. We have some cooperation with RDF guys as well, and what we learned, they are interested just now in point geometry, like addresses and so on. Is there any pilot using more complex geometry or topology on the base of RDF?
Good question.
I can't really answer to you. I don't know if you can maybe help me with that since you are the pilot.
We have line strings and polygons.
For displaying? For displaying the information,
Yeah.
or just you can
No,
work with it on
Published on RDF.
publish? Yes. Thank you very much.
Okay, thanks again. Next presentation is up by Raf Buyle from Flandre. And while Raf comes here to the microphone, Raf is using this picture of Catch-22 to explain us about location-based services. Go ahead.
Thank you.
Go ahead, Raf.
Good morning. I'm Raf Buyle and I'm representing the Flemish Information Agency. Our agency is at the crossroad of local government, federal government, private sector and the citizen. And I would like to give you some insights on how we can lower the cost for publishing data and how we can lower the cost for our reusers. Because we still think the cost for reusing public sector data is high. The cost for adopting the data by our users is still high. And also, we see that we have an increase in data sets, we have an increase in users, we have an increase on the load of the server. And this stresses our servers, and it needs to shift us to scale up the infrastructures, which is very costly because at the same time we face budget cuts, we save pressures on our budget. So this is kind of a paradox, a catch-22. We want more users, but we want less budget. So what we've done for the adoption, we rewired our address database to a 5-star linked OpenData base registry. So this registry is containing over 4 million addresses as linked OpenData, and it follows the principles of the semantic web as coined by Tim Berners-Lee. So the first principle is we're using persistent identifiers to identify an address, which is displayed at the top. The second principle is we use identifiers that are dereferenceable. For instance, when you take a book, in the book you have an ISBN number, but when you type it in on your browser, the browser won't understand you. So when you type in this identifier, the browser will answer. We answer with human-readable data, but also with machine-friendly data by content negotiation. The data that's provided is in line with European standard and with international standards. And the fourth principle we are applying is what LinkedData is all about. It's including links. Just like the web is more fun when we have links to browse the web, for humans, the web for data is more valuable when we include links to other data sets. Now, we have provided 3 kind of products, 3 kind of linked open data products for addresses. The first product is a data dump. This is one static file which can be downloaded and contains all the addresses, so over 4 million addresses as linked data. The second product is a subject page. When you dereference a URI, when you type it into your browser, each address has its own web page containing information for humans and also for machines. The third product is a Sparkle endpoint. This really exploits the power of linked data. It can be compared to, so Sparkle is like a semantic querying language, which can be compared to SQL for plain vanilla databases. But although the Sparkle endpoints fully exploit the strength of linked data and the web, we face a problem because they are quite expensive on the server side, because they take a lot of power of our CPUs. So we wondered, what's the reason? Because a regular web page can be served quite easily on the web at no cost, because you can use the caching of the web, because it's in line with the architecture of the web. But with Sparkle endpoint, we see there's like a layer on top of it, the classical HTTP caching, and it's quite expensive to publish a Sparkle endpoint. So when we put it when we take a look at the playing field, at the left side we see the data dump, our static file containing all the addresses. At no cost, it can be, we just put it on our server, but it's very costly for our end user because they have to put up their own infrastructure. At the other side of the spectrum, you see the Sparkle endpoint, fully fledged, which provides comfort for the users, but it comes at a cost. So we wondered, have we explored all options? Can we have the best of both worlds? So, yes, we can. Wow. We applied the principle of linked data fragments. So on the left-hand side, you have a figure which displays a Sparkle server where all the load is on the server. The server does all the calculations. On the right-hand side, we have another figure which displays the linked data fragment. What's a linked data fragment? We take the whole data set and we create partitions, smart, intelligent partitions, which will be a lot of files, which look like tiles, but containing structured information, and with an index on top of it. This allows us to provide files which are just static at a low cost from a server point of view, and because it's a simple interface with links which can be followed by clients, also the clients can at a low cost process the information. And in this way, we balance the processing power between our central server and the clients which are using our services. So we have prepared a small demo with a client application which will display how the linked data fragments work. So we've published over 4 million addresses. We've published them as a lot of files which look like tiles, which are visualized on this map. And the tiles, they contain structured information, linked information. All the documents, they are context aware. There's not only an index, but there are also links between the documents, which looks like regular hyperlinks. Now, these documents, we will see in the demo that they can be cached on the client, so requesting data over and over has no impact on the server. And they even can be cached on the server because they are in line with the principle of the web, a RESTful architecture, a truly RESTful architecture. Also, the web server doesn't need to process them, it's just in the cache. So I will try to give a small demo. The links to the demo and the services are also in the presentation. No, it's not working. There's the browser. Okay. So this is our demo. So it's a client, just a web client with some HTML and some JavaScript. And the purpose is to explain the principles. But imagine there are hazards and you need to provide the addresses in a certain area. Then what we will do is we will check what tiles will intersect with the area. So the server is providing a lot of tiles. We're using an R3 mechanism to split our address database. And each tile is containing approximately the same amount of addresses. And when the server follows a link, which links to the file, then we will retrieve the addresses. And because the addresses that we are retrieving are in like a fixed B box, we can predict what the server will, what there will be requested to the server, and we can cache them as tiles, which has a higher performance than queries, which has an infinitive combinations. So now the server gives us some addresses as linked data containing also the coordinates, and the client can filter them or can follow another link, which is the URI, which uniquely identifies our address. And when I click on it, I will be redirected to a subject page. And because I'm using a browser, I can see data in HTML, but if I was a machine, by content negotiation, I could ask for a specific linked data format and it will be provided. And also there are links, so I can click to other streets. These are the links that make the data more useful because I have hints to other data sets. So I go back to my presentation. Voila. So what have we done? We have chosen for linked data because of its interoperability. We wanted to provide an interface which is very rich and can be queried, but it comes at a cost. So scaling linked data Sparkle endpoints is quite expensive. Because of that, we had a catch. The catch, we would like more users, more reuse of our data, useful services, not just data dumps, but services which can be queried and reused online and combined with other services, but it comes at a cost. Therefore, we reassess the trade-offs between the capacity, the CPU capacity of the server and the CPU capacity of the client to help us overcome the catch-22. So we did find a solution in between, kind of best of both worlds, linked data fragments as a hybrid solution. Does this mean we are going to stop using Sparkle endpoints and other products? No, but for a lot of the questions that will be asked by our clients, this could be an answer. So we are focusing on a new querying paradigm for publishing linked open data. Thank you.
Super, I think that was a very convincing presentation, very clear. I learned a new term, linked data fragments, the latter part. Excellent. I could assume there's a question or two. Yes, again, from the first row.
Yes, hello. I understand the interest of the fragments here, and they are built within geospatial dimensions. But the power of Sparkle is to be able to do graph queries on what, the expressivity is limitless. Mm-hmm. What if I want to do a query like find me all the swimming pools in towns of less than 10,000 people? You would have to still retrieve all the tiles, don't you? Or, yeah.
Well, we are experimenting on. I've mentioned that the tiles, they are optimized for certain questions, and we're building like kind of an index. Yeah. So we're optimizing for several questions. Like we have one use case where it's related to time for linked connections, for tracing how can I go very fast from point A to B. Now we have tried it with geolocations. So now we are researching how we can add intelligent questions, but it will be a balance between the client and server, doing a bulk filtering on the server and retrieving data, and then doing more fine-grained filtering on the client. So it's a good question, and we're still researching how we can handle, because if we look to the legacy of a WFS server, which has such fantastic, you can ask to simplify something, and so we have to think how we can migrate those fantastic optimizations for GIS towards the linked world, and to do it in a way that it comes at a reasonable cost.
Another question? Yes, here from the front. Udo?
Can you maybe tell us if the fragments are made on the fly or are they prepared?
We tried both because at first we thought first we did it statically, so with an algorithm we have splitted them R3 and on a server, and it worked well. But then we tried it in a database, and the performance was the same. Why? Because when you can predict the question, then the second time when you get a question, it is in the cache, and when you get a lot of load, it doesn't increase, the server load doesn't increase linearly. So we've tried both, and the results were approximately the same.
Good. Last question from
just the flash one. Are you planning in the near future to have a look on some sort of evidence about the saving of money and time for certain side of data, which would help us also to have something in the hands and to go back home and to justify that, look, it makes sense to invest in this initiative. Thanks.
Okay, thank you.
All right, thanks again. Next presentation is by Martin Demeyer from a German region about what he calls the Inspire Laundry. Oops. Did I get lost somewhere? How do we get to? Ah, no. That looks good. Voila, Martin, here you go.
Okay, good morning, thank you. It could be not so easy to finish my presentation at 10 a.m. So it's much easier to implement Inspire, and that is the topic.
You have 15 minutes, you start.
Okay, I can try to transform it into a speed presentation too.
No, you have 15 minutes.
Thank you. Okay, the first part is to explain you something about Inspire implementation in the southern part of the state of Hessen, of the German state of Hessen, from an organizational point of view. The second part is some technical words about our solution from Andreas von Dömming from WeTransform. Okay, we had a long way to Inspire. The SDI consortium Southern Hessen, called GDI-Südhessen, is working on Inspire or on interoperable spatial data since 2005. And Inspire implementation is only goal 2. So we thought out of the box from the beginning. The regional SDI was the main goal of our region. Okay, and when we speak about a regional SDI, of course, LinkedData, modern technologies are important, but now we have to talk, or we have to do the basic work. We have to publish the basic data to think about modern technologies. So that's our thematic topics at the moment. Okay, in 2007, everybody looked like that guy in the bottom left corner. I think that's clear. But today we have a so-called Inspire Laundry. Why do we use that symbol for our solution? I will try to explain that. First of all, a laundry means you need an operator, an administrative and organizational operator. That's the GDI-Südhessen, the region of southern Hessen. It's a cooperative initiative on district level. Okay. But the heart of a laundry, that's clear, is a washing machine. So we need a washing machine provider. That's WeTransform with the software Inspire GIS. It's a cloud platform. I think you heard about it at the Inspire conference. And we use a customized private cloud solution called GDI-Inspire that could be translated with SDI Inspire Implementer. Okay, a washing machine. That's the symbol, because it is easy. You have to upload data somewhere, put data in it, and have to press start. That's it. We talk about district and municipal level. That's the best way that works. So we have non-expert users, and so it has to be easy, it has to be intuitive, and it has to be automated. So that's our solution. Okay, when I say it has to be automated, we need something to have automatic processes. So we have fully pre-configured washing machine programs. That means we have Inspire schema mapping. No municipality has to deal with schema mapping. That didn't work. That includes metadata, network services, in case of view service, portrayal, and so on. So it's fully pre-configured. And another point that has to be considered to have an automatic process is pre-sorted data. So we have harmonized data models in the region of southern Hessen. These are models that are easy to provide. It's no Inspire data model. They're user-friendly. As I said, we have the first goal, regional usage, and it enhances regional administrative processes. Okay, and step 2 is serving Inspire at this point. Okay, to come to harmonized data model standards, it's a long process. So we do deal with different topics or different themes step by step. So you see some symbols at the bottom. There are schools, rescue stations, land use planning. These are the medical information that is already published. There are more topics like water, sewer networks, streets, and so on. Okay, the output of the washing machine, it's clear, harmonized data. That's what we use in the region of southern Hessen. And beside, we have Inspire compliant data services and metadata. Okay, some words about the organizations or about the users of the Inspire Laundry. There are potentially about 250 public authorities in the metropolitan area of Frankfurt, Rhine-Main. There's only one requirement. They have to upload and update their harmonized data. Okay, they have to harmonize data, but in the regional data model standard, and that is possible for them. Okay, and some words about the costs. They are €1,000 per using organization per year. Some years ago, everybody was convinced that that would be very, very expensive. So I think €1,000 for a washing flat rate, a coordination office that is responsible, and a supporting partner, and for more than just implementing Inspire, I think, in my opinion, that's a great deal. Okay, now Andreas will tell you something about or why the platform is very reliable and compliant to Inspire.
Thanks for the first bit.
Thank you, Martin. So, well, we are also in the exhibition area near the entrance, and we are, the last day we make some demos non-stop. So I won't show you a live demo. Please come to our booth near the entrance. But I'd like to focus now on the output of the washing machine. Yes. So what we create
when a user, well, runs this washing machine program, well, we publish the data set, and we publish services from this data set. So there are view services, download services, and WFS, and also predefined atom feed services. And we publish, of course, also the metadata. So metadata are the capabilities of these services. This is also metadata. The data set metadata, and all the service metadata for each service. Well, you know, with metadata, there are always some challenges involved, because many information occur in many of these documents, and they need to be synchronized. So metadata is quite complex, and it's also, well, we are here now in the linked data session, although we didn't expect to be here. But actually, these metadata is also linked, because there, for example, you have links from the service metadata to the service capabilities. You have links from the service capabilities document to the metadata of the service, but also to the layer metadata. There's a link to the dataset metadata. And from the service metadata, you have these operates on relation to the data set. All this needs to be synchronized. If you do this manually with many systems, one for the metadata, one for the services, you're always behind. So one change on the one system needs some follow-up changes on the other system. So what we actually do, we manage all the system. That's really helpful in keeping these things synchronized and compliant. So we will have a lot of automatization in these processes. And what we also do, we test this compliance. So once we've published something, we immediately start testing this. We're using the GDI test suite, because it has some Inspire tests. It has also tests for some German profiles, and we're also looking forward to use the test suite that has been presented here at the Inspire conference. So we have automated testing. We test all these resources immediately after publishing, and we present the results to the user, so the user can then access to the test reports, and so, yeah, well, he has a proof that everything is okay. And yeah, there's another thing that's very important, quality of service. So Inspire requires a certain performance. Inspire requires a certain capacity for your services, and also availability. So happily, we have a cloud solution. So we can use the best data centers to run our applications. This is very helpful to also ensure these performance criteria. So if you go with us, and it's, we ensure these performance criteria for your data and for your publication. So it's very important on the local level for these administrations. They don't have a data center that can handle this. So we offer a public or private cloud solution. This is very helpful to ensure these quality of service. So thank you very much. I want to invite you to at the exhibition hall to our stand, so we can show you a live demo if you like. But there's also this map guy you see here. He's called Beppel, and he works 24/7 on YouTube explaining what we did. And yeah, also you can ask Martin. So he's the one who knows how to implement Inspire in with local organizations, how to manage this, to get them convinced to do Inspire. Of course, these local organizations do it not for Inspire. They also publish these harmonized data sets with made for use cases on the local level, but with transformation, it's also transformed into Inspire. So they have both their own benefit and also they're compliant to Inspire. Thank you very much.
Thank you guys for these success stories from the washing saloon. Are there other questions to Yes, here. Indeed, that was the least linked data-related presentation.
Beautiful presentation. I think I have a question for Martin. This whole system relies on having the local administrations and municipalities harmonize their data into shapefiles. This is what I've seen at the demos. How did you get them to do that?
Of course, they all have a GIS. They all have a GIS administrator, and they are able to do that in our region. So,
how did you get them to actually do it?
Okay.
Is it top-down? Is it top-down?
No, it's bottom up. So it has to be much work to convince them to do that. Use cases and so on. But it's step by step. It's not the fact that we say do it and everyone says yeah. So we need some time, but it would be better.
I think we learn in many contexts that this success of Inspire or SDIs in general is certainly not mainly a technology question. It's a governance question, and that sets the frame. And within this, we have now a lot of good technologies, increasingly good technologies to do the technology job. Another question? Okay, thanks again, guys. Last presentation by Paul von Genuchen from GeoCut. And there he is. And I'll help you into your presentation. GeoCut is another of these companies who are active in the Inspire area. And we will learn, I guess, whether this is really a conflict or what the difference is between OGC Inspire and the open linked data and open data notion.
Hello. I have to start with an excuse because I missed the first session from Clemens and Lorena because I had another presentation in another room. So I don't hope my message is too much the same. But this proposal was originally created by Maria, and I'm taking her place because she couldn't make it today. So this is us. We do a lot of stuff in various communities. This is a picture from my colleague Linda in Geonovum in the Netherlands, which she used in the Geo4Web. Did Clemens show this or not? No. Oh, good. So this is actually an image how we think the world thinks about us. We think there is a big wall, but the wall isn't. That's not a wall. There's walls everywhere. So these are 5 or 6 communities out there, which have some form of standardization. So you see the Open Knowledge Foundation group, you see the OpenStreetMap kind of group, you see the LinkedData group, you see the search engine group. They all have their somewhat standards, and they try to engage with each other, but there's insimilarities and challenges. And our group is actually doing quite fine. We have a lot of standards which are really well organized. We have a lot of data sharing, so we're doing fine. So this is more what happens on the web. There's not a wall. So from this picture, what we can see is that the interfaces between the communities are the important aspect. So how can these communities engage with each other? And then it really helps if you have good standards already. So this is the thing that we did on Geo4Web. This is the traditional SDI with their standards. There was a proxy layer introduced on top of that, which exposes our standardized data to all these communities in a very easy way. And we could do this because we have all these standards in place. This made it a simple exercise. The challenges are up there. So how can we communicate to the Open Knowledge Foundation? How can we communicate to the OpenStreetMap community? Because there are no standards there. So but we have some universal rules to use, and one of those is the URI. So it all comes back to the URI. I'm so happy I heard URI a lot of times in this conference. URIs for features, URIs for catalog records, URIs for everything. But Inspire helps out. This recommendations are from specifications which have been 10 years out there. And I don't see a lot of you using this recommendation, but it's out there. So that's why I'm very happy about this, the stuff that Lorena has been presenting, which I missed, unfortunately. Go read it. So one thing, so we have this data set, this Inspire data set. It's called buildings, or it's called Bach, something. It's a data set. What I see a lot in implementations is that people use this. So this is how it's used on the where people create draw houses in, but then it should be Inspire. So what I see a lot is that they transform it into a new thing, the Inspire data set, and then put it somewhere on the web. Well, there's some really big challenges there because it's not the same data set anymore. It's transformed. It's 2 months old. It loses some information in the process. This is another way to do it. Keep the same data set and annotate it in a way such that it can be recognized as an Inspire data set. And I think this is an important feature, and it well aligns with this open government data second principle that data should be primary when you put it on the web. Everybody finished reading it? It's important. So, some use cases about standards between the communities. We see this a lot. So we have a lot of nice metadata, but we want to expose it in open data portals. So we do this ISO to DCAT transformation. Arena worked on that. That's great work. Yeah, so we may need some other protocols than CSW because the Open Knowledge Foundation or the DCAT community is not well aware of CSW. And there's some challenges. This is what we see very much in the Netherlands, that if you look for a certain data set on one of the popular search engines, you get 4 or 5 hits for the same data set because it's harvested by 5 different portals. And that WMS protocol is not well understood by the open data community. One could even argue if it's open data or not. Well, this is actually the similar use case. The other one is about the RDF. This one is about the search engines. So we can have also the schema.org annotations in the HTML pages to facilitate this use case. Oh, this is one I'd like to focus on. It's actually one of the things that we're working now on with the LD proxy. That you also need to provide value. If you have an HTML representation of your coverage pixel, then what is the value of that? So you have to be very critical there. If I proxy my coverage pixel to the crowd as a web page, is that useful? And how can I make it useful? Link it to Facebook, link it to whatever, but make it useful. This is the other one, which I think is interesting, and probably we do this next year on the Inspire conference. How so how can we, if we have all this data exposed on as RDF, how can we make smart queries on that data? I was actually pointing to this one. The other way around. So there is all these. No, sorry, I'm mixing up. Trying too fast. This is targeting the API specification guys, the API developers. The LD proxy tool. Probably Clemens talked about this. Can have simple APIs to WFS. I was talking about this one. There is all this nice RDF data out there, but how can we visualize it as a GIS layer? that's going to be a topic, I think, and this is one of the possibilities it might go to. So we have a quantum GIS layer, which is based on a SPARQL query. Or there may be a WFS in between, which uses the SPARQL as a base for a layer definition. So, is the future in LinkedData? Is it an if or is it a when? I don't know. We see both OGC and Inspire intensively doing research on the topics. We see a full coverage in this room, so I guess it's more a when than an if. A potential direction for data providers. A lot of Inspire-based data is still this. Is a CSV or a shapefile or something. How can we annotate this so it becomes RDF, and with RDF also Inspire? So first we indicate is a thing. For example, is an Inspire hydrography watercourse. Then we say, well, we have to mint a URI, so we take the identifier column and we put some namespace before it. And then we link concepts to the various columns. This is in principle how you would make linked data of simple data. But you don't touch the data. The data keeps the same one. So in JSON-LD, this would look like this. You have the context, which you put on top, and then you have the actual data below. And then there's this standard, ISO 11110, feature catalog metadata. This is where you, in the OGC context, TC211 context, describe a data set with. In the work that we're currently doing for 2 water authorities in the Netherlands is that we use this standard to add a semantic link in each attribute description. So we're doing this process already within our catalog tools that we know to already create linked data from these simple kind of shapefiles. So we did a lot of work. Is RDF a good alternative for XML, or is it the only way to go? And the fact that we're already highly standardized, it really helps. Thank you.
Okay. Thank you, Paul. I think you may trigger some reactions. You had a provocative question on your last slide, the slide before. I think it's not an either or. I mean, it's not an either or. I mean, there are certain Inspire format. There is RDF. It adds value, but it's not. It doesn't replace. Anybody wants to comment on that?
Hello, Peter Paslow, Ordnance Survey in UK. I think it's a great insight that the web's actually got several sort of disjoint communities that cluster around different technologies, sort of standards of their own. So that some of our web developers aren't too sure about adopting the W3C best practice because they say, well, that's not the way the web works. And you kind of wonder whether the W3C know that. I wondered if you could comment and perhaps even put that slide back up again on which of those different communities we should perhaps prioritize building bridges to. So obviously OGC has been building bridges to W3C because it has a formal existence and you can talk to them. Any thoughts on some of those other groups?
Tough one, eh?
It's a tough one, yeah. I'd go for the search engines, and schema.org, but that's me. So even W3C, I hear them say, maybe we should, some of them say we should get rid of all those ontologies and just use schema.org extensions, so we have one ontology to rule them all. I like the OpenStreetMap community also, but I would want to help them standardize a bit more and then connect to them.
What is this actually here?
CCAN, Open Knowledge Foundation, data package, yeah. Is also a lot used. OData, StatDcat, SDMX. I'm not very much into that. I have to talk to Peter a bit more. Yeah, are you using OData or not?
Yes.
Okay. Yeah. Good. Yeah.
Any other?
Sorry, Peter. I don't know. It depends on the use case. It's always the use case.
They will still wait to make a choice.
Maybe more a comment than a question, but you made an important statement about the coexistence of geo catalogs and more generic catalogs like CCAN, for instance, and how they map or don't map. And so I happen to be a CCAN developer involved in several governmental open data portals, and that's a question we hit all the time. How do we map geospatial dataset services into the models that, for instance, what do we have in CCAN? And I think there's room for a best practices or recommendation paper on that, and maybe some interaction between the Inspire community and the EPSI to, because I mean the people in the at least in the governments I work for don't really know how to map these things together. So
thanks for the call. Thanks for the encouragement.
Yeah, so in the Netherlands we have a quite active group in the CCAN world, which have this. They use this DCAT app kind of schema in there. They try to use it in their CCAN implementation, but they run into challenges. And yeah, I should engage with them more. You're right.
Raf is having another contribution.
I have two small comments. One on whether to use schema.org or European standards, and another one on the mappings. We're facing the fact that we've invested a lot in aligning our vocabularies, our data on European standards, Inspire and ISA. It's a very rich format. When you look at schema.org, it's a very popular format because it came from optimizing web pages, and now it's like used for exchanging data, such as Google. So what we've done, we've written a position paper together with other member states to European Commission, asking, let's make a formal mapping between schema.org and European vocabularies, but let's in a short-term strategy promote our data in schema.org because we have 10 million sites supporting it, but adding in our webpage a see also statement in RDF to the European vocabulary, because I believe if on a European scale we are going to publish URIs and vocabularies all in the same format, now we have Google, yes, and Google and they are working on schema.org, but I think there will become more bots and more automated services, and if we publish a lot of data in line with European standards, then it will be adopted the way we look to our data, because schema.org is not really meant for exchange and is not a fully fledged supporting our concepts. The ISA Commission, the ISA program, they have published a formal mapping on how to map your vocabularies on other vocabularies based on SCOS, but more as an evaluation method than as a data mapping method. It's in the handbook using the core vocabularies. And I think should we do schema.org, I think we should map it and use it to promote our data, but in the end focusing on the European standards.
Yeah, I totally agree that we need authoritative vocabularies and ontologies. So Inspire is a good initiative there.
We put a lot of effort in Inspire in describing a building and address, so we should stay on track and take focus on that.
But mapping it to common ontologies like DBpedia, OpenStreetMap is important also.
Yes.
Yeah.
It is.
Okay, thank you very much. Briefly wrap up the session. I think we had excellent speakers, very relevant, good presentation, crisp messages. I think what we are learning overall that Inspire and LinkedData, that is growing. I mean, LinkedData is growing in its importance related to Inspire. Just from your remark, we heard also how other semantic aspects are growing. So I'm looking forward to see next year how we are with this topic and how many more applications, solutions we have which are outside the initial thinking of Inspire, which did not bring much linked data or semantics. Well, we brought semantics in, but not in this form. So I think that's a super topic to keep looking at. I think that markets are out there. We want to bring our data out to many users in different ways. So I think these technologies help us a lot with that. Not just having the basic formats around Inspire. So thanks again to everybody. I think there's coffee break now, coffee or tea. So enjoy the rest of the conference. Bye-bye.